which is asking us to construct and interpret a 95% confidence interval. So what's the very first thing if you need to create and interpret a confidence interval? What's the first thing you should do? Actually, no. If it was a test, Diego, then you would need to define the parameters. But it's not a test. Don't need hypotheses. Assumptions and conditions is the first thing you go to. All right. So independence. Diego, do you got independence here? No, you don't have the sentence? Anyone? Ezekiel, you did some work. What'd you write down for your independence assumption? I put it behind Anthony.
I went straight to
the like doing the answer. See, the thing is, you got to do this too, though. You're not going to get full credit. What do you mean it wasn't in the thing? It was there. I can show you later. Who's got the statement then?
Oh, I have it.
Yeah. No, that's not true. Yeah, I'm recording, so maybe we could, refocus. Do you need 19 or 20? Why don't you check? Couple Fridays ago? Why don't you check Power School? Just nobody wants to say the statement? All right, Joshua, here we go. Joshua, give it to us, Joshua. Okay, let's try this. Shh. Let's try this. We're having some issues here. What did this person at this company find? You okay? If you read in the paragraph, they found just imagine like a big box of components. Did it say if it was grade A, grade B, or grade C? No. So they're going to sample, right? Reach in and randomly sample 200 of them. So now take one of them from the 200 and test it. Is it working or not working? What do we think? Doesn't matter. Whatever it is, will that affect the next one? No. So that's what I'm trying to say. So one component being defective will not affect others. Thank you. Okay, what's after that? Does it say anything about random sample? It doesn't? There you go. Boom. I'd say it's a random sample of 200 components. So random sample of 200 components. Okay, what's next?
Large enough.
Yeah, essentially, this is the sample size 10% condition to make sure it's not that it's large enough, Eric. It's actually to make sure it's not too large. All right, so what do we have to do? Okay, when you say multiply, what do you say? What's it? Very good. So n times 10, which is 200 times 10 equals 2,000. Now, I don't know anything about this company, but in order for me to feel confident about this, I need to make sure that this company is doing what? Making more than 2,000 components. So I'm going to write down that I assume the company is making more than 2,000 components. If that's true, then our sample size is not too large. Now, Eric, we're going to switch to, we need to make sure that it's large enough. So I'm going to write down 200 components is a large enough sample. Oh, so you have like an extra one and a okay. Multiple copies. Got it. Duplicates. All right. What I have to do, the last thing here before I write my statement. Success, failure. Now, let me make sure we're on the same page here, guys. If you've got to run an interval on Wednesday/Thursday, Alex, if you have to run an interval on Wednesday/Thursday, you're just going to use the data from your sample. So how many did they sample when they reached in? 200. How many successes? 16. I know it's weird to say because that's actually 16 defective components. All right? So if I subtract 16 from 200, I get how many failures? 184. And what do you notice about those two numbers? They're both 10 or more. So both greater than 10. So our sample size is large enough. All right, now for our last statement. The conditions have been satisfied. So I will use a normal model to run a one proportion. It's not just one proportion. Z interval. You would know if it was two because there would be two samples. Not probably. There would be two samples. Right? There's only one sample, right, Joshua? Just these 200 components. Yeah, if there's another group where they do another sample, that would be a two proportion Z interval. But this is just one. All right? So make sure you're ready for this Wednesday/Thursday. So let's do our mechanics. So write down what we know. Sample size 200. Number of successes 16. So our p hat is 16 over 200, which is 0.08, right? 8%, not 80%. Who remembers the formula? That's the standard error of p hat. I'm just asking for the formula for the confidence interval first. Say it again. P what? P hat. Thank you. Plus or minus Z star. Now, Diego, times the standard error of p hat, which is square root of p hat times q hat over n. There you go. Look at you guys. Nice. Remember, don't expect to get this on Wednesday, Thursday. What Z star? Nice. For 95% is 1.96 times the square root of 0.08 times 0.92 over 200. How did I get the 0.92? Just subtracted the 8% from 1. Now from here, I'm going to go to the calculator so I can actually get my interval. So if you don't have a calculator, make sure you get one. Samantha, do you need one? You got one?
Second floor.
It's not second.
Okay.
Nice. What up, Mia?
Staff.
Maybe with a little less attitude, but I like it. Are you okay over here?
No, he's not.
Okay. Good to know. Which is very appropriate for problem number 2.
Is it?
Yes. Talks about Swedish men and having strokes.
Is that a thing?
I'm not sure if you're Swedish, Ezekiel. All right. Ready? Stat. Test. This is a one proportion Z interval, which is letter A. All right, we've got 16 successes out of 200. And it actually, we're good to go on the confidence level. It asks for a 95% confidence interval, which is 0.042. So we have 0.042 all the way until 0.118. All right. So now, Ezekiel, it's time for that statement. Do you have your statement? Go ahead.
I am 95% confident that interval values for the percentages of defensive between 4.2% and 11.72%.
All right, so this must be what you guys feel like because that was way too fast. I can't copy that down. So I'll say what I'm going to say, and then we'll see if it matches up, okay? I am 95% confident that the proportion of defective components in this, and I want to get the name right. Is it a box? Where did they find these? Is this a box? A batch. Found a batch. Yeah, in this batch. In this batch is between 4.2% and 11.8%. Okay, say yours again, Ezekiel.
I am 95% confident that the interval of values for the percentage of defective is between 4.2% and 11.7%.
Okay, so a couple of things. You mentioned defective, which is good. You didn't say the word components. Defective what? Shoes, right? So defective what? And then I would say that you want the person reading this to know that you're talking about that even though you only looked at 200 of these components, I don't know how many are in the batch, but I'm expecting it to be more than 2,000. So we want to say the proportion of the components in this batch that they found. All right, so something to know that you're talking about that particular population. Okay? Any questions on A? That's A. We're not done yet. We still got to do B. Any questions on A? Okay, so letter B says, does the interval that we calculated in part A allow the company to clearly determine the grade of components that was produced in this batch? So let's just do grade A. From the top, it was 2%, I believe. Is that what it says in the top? Is grade B 5%? 5%? And then what's grade C? Thank you. All right. So look at your intervals. All right. What's our low one? What's our low side? No. What's our low side on the interval? 4.2%. What's our high side or max? 11.8%. So are there any of these that I can rule out? A, yes. No, 10% is in there, right? 10% is between. Oh, my bad. I'm sorry. So 2%. This is the only one I can rule out. So 2% is not in our interval. So this batch is not grade A components. Now that stinks, right, for our company? Why does that stink for our company? Because grade A components are the best. And if this batch, however many thousands it is, was grade A, what could we charge for this batch? A better price, right? We can charge more money if the components have a better rate. All right? Now let's talk about B. Is 5% in here? Yes, and we already said 10% is in here. So can we narrow it down any more? No. So all we can say is because 5% and 10% are both in this interval, it could be grade B or C. Look at that, guys.